So we will get started. So first of all, welcome to everybody, and thank you very much for joining our broadcast today. I'm pleased to introduce Sashi from SolidWorks Corporate. Sashi is the Senior Simulation Technical Sales Manager with DS and SolidWorks, and has graciously offered to put on this presentation for us. It's a bit of a preview for what we'll be seeing as part of our upcoming live events in Calgary and Edmonton in a couple of weeks' time, and then on to Winnipeg. So today's presentation will be focused on integrating design validation into the product design cycle to solve multi-physics problems. So a very interesting topic, one that people have raised their hands on and have asked for more visibility and more of an understanding on how that design validation portion within simulation can be incorporated into their day-to-day designs. So our presentation is going to be about 30 minutes today, and we are going to have a polling question to make sure that we're on top of your inquiries and get your questions answered. For those of you that are new to Javelin or haven't worked with us previously, we are the largest SolidWorks reseller in Canada. We literally go coast to coast with 6 offices in all the provinces across the country. We provide 13 hours of technical support, which is very unique in the SolidWorks channel. As you can see, for those friends joining us in Western Canada, we have a significant footprint. Winnipeg, Calgary, Edmonton, and Vancouver are all key locations where we have a fully supported staff, product specialists, and a lot of our technical support and services team. If you've seen this before, you know how we approach our success to working with our customers. We break it down into 4 pillars. Today, we're going to focus on technology and leveraging design validation, everything that's available to you within the simulation suite, and understanding how important the aspect of getting out in front of your design validation is in your design process. Of course, when we talk about process, we talk about the integration and collaboration with your simulation team and your FEA needs, collaborating with your ECAD and your MCAD people, and making sure that ties nicely into PDM so that everybody's organized. Once you have all that, we move into the manufacturing stage, and this is where a lot of our customers get excited, because this is where all their hard work finally pays off. Their products are manufactured, they're going out the door, and they're starting to make you money. Of course, none of those 3 things happen without the investment in your people. We work very closely with the job grant programs in all 4 provinces in the West. It is our mission to make sure that all of the people that we work with and all of the companies have adequately trained SolidWorks and simulation engineers, so that they are leveraging everything that's available to them in the investment that they've made in SolidWorks and the investment that they've made in simulation to speed up their design process, to make their products better at less cost, and that they're more reliable. With that, I'm going to turn it over to Sashi, who is going to run us through the presentation. Sashi, over to you.
Thanks a lot, John. So welcome, everyone. Thank you for joining me today during your lunchtime. Hopefully, you'll learn something today in terms of running some multi-physics analysis within SolidWorks. So essentially, for this webinar, I wanted to touch on a problem simulation that we are having with a volute pump. And before I jump into the requirements for this analysis, just a quick note: if you have any questions during this presentation, there is a questions menu in the GoToMeeting panel. You will be able to type in your questions there, and at the end of this presentation, if time permits, I'll try to get to some of those questions live during this webinar. All right, so essentially for this webinar, we're going to test out this volute pump, and the multi-physics environment involves the airflow of this pump due to the rotation or the rotation of the fins. And once we have that fluid flow rotation, we want to assess what the stress would be on those fins due to the airflow and the fluid pressure on the pump itself. So this is what we would consider an internal analysis. For the fluid, we'll be just using a simple water in this case. So it's a rotating impeller at 1180 RPM. And the flow rate desired is 150 GPM. And the outlet duct side exposed to ambient space. So this is a very typical pump setup where you have water going in, coming back out, and it's rotating at a certain RPM, which you'll be able to set, and also a certain flow rate of the fluid traveling into the pump itself. So let's jump right into SolidWorks, and we will take a look at this model. So if you're not familiar with the simulation offering within SolidWorks, so we have right within the SolidWorks add-ins, we have our two major analysis products is the SolidWorks Simulation, which calculates structural deformation, structural stresses in any of your parts and assemblies. And we also have SolidWorks Flow Simulation, which is our computational fluid dynamics analysis package. In addition to these two packages, we also have SolidWorks Plastics that runs injection molding analysis. So we still consider that an analysis tool because it simulates reality. And last but not least, we also have a SolidWorks Motion analysis, which is backed by atoms. So any type of assembly or parts in motion, you'll be able to evaluate the kinematics of that that type of analysis. So for this example, we're going to focus mainly on SolidWorks Simulation and Flow Simulation and how these two products talk to each other within SolidWorks itself. Right, so we want to be able to run a computational fluid dynamics and extract the results from the fluid dynamics and apply those results into a stress analysis in SolidWorks Simulation. So to walk you through this analysis setup, so for time's sake, I've set up the analysis, but we'll talk about how the analysis was set up, how and how to collect the results and transfer that to simulation. And we'll take a look at how we can set up the analysis in SolidWorks Simulation as well. So right off the bat, the one thing that I really like about having the ability to run the simulation within SolidWorks is everything is fully integrated, which means I am within my design space, right? So if any of you are existing SolidWorks users and have used SolidWorks before, you know that if you need to change anything in terms of dimensions parametrically, everything can be done easily, right? So if you double click on any of the features, you'll be able to change the dimensions directly within SolidWorks itself. And the same thing applies to our simulation tools. So as soon as you select, so you can see how these add-ins are indented, meaning the simulation tools turned on. It will create a tab here for Flow Simulation, and it will create tabs down here for SolidWorks Simulation. So at any given time, I am within both my simulation space, where I can set up my simulation constraints, and I'm also in my design space, where I can go back into my assembly. I can come back in here. I can change my mating conditions. I can evaluate the mass properties of the system. I could run some measurements, right? So your day-to-day SolidWorks features and tools are still available even while you're in that simulation space or that simulation mode right now, right? That okay, you're done with your modeling, so now you want to start with the simulation. And this really helps, right, with design changes. So if you ever have to change anything with your analysis, um, it can be done without having to leave this main user interface. So with that said, let's talk about the flow simulation setup that we have here. So as I had mentioned, once you turn on the add-in, it brings up this tab. So this tab will basically list out all the different projects that you have for this assembly. In this case, I have 4 projects where I've ran the analysis at different GPMs, right? So 150, 200, 400, 500. So for this example, we're just going to look at the 150 GPM example. Um, so what's really nice about having these projects listed here is that this can also be configuration driven. So if you have several configurations in your assembly, you can have several configurations and several projects attached to those configurations. The number of projects you can have is as many as you want to create for that assembly, and it does not increase the file size, because all it does is it retains the simulation setup itself. It will not increase your assembly file size or your part file size uh, when you have a number of these analysis attached to it. Okay, so for this analysis, we always want to start with our initial conditions. So initial conditions is within our general settings of the analysis. For flow simulation, there's several types of analysis we can run: convection, conduction, forced convection, radiation, time-dependent analysis, gravity-dependent analysis, rotating components, internal, external. All these types of analysis can be ran in flow simulation. So depending on what you're trying to run or what you're trying to get out of the analysis, you can pick and choose the physical features to include into your flow simulation analysis, right? So for example, in this analysis, all I want to do is have water flowing to my pump, have it rotate, and have it come out the outlet, right? So I don't really have any radiation. I don't have any heat conduction. I could have heat conduction if this was heat treated as well, or there was a heat source, but that's not a concern for this specific analysis, so I don't have to click that. Gravity is not a concern here. Typically, if I have gases that are flowing in opposite direction of gravity, then I would typically would include gravity as well. This is not a time-dependent analysis. This is a steady state analysis where I want to collect the results when I've reached equilibrium. So I will not check time-dependent. So I'll just leave rotation as the only checked physical feature here. The next thing we want to do is specify the fluid. So in this case, as I mentioned earlier, it's just going to be water. But just for your viewing, we do have a number of different fluids. Gases are considered fluids as well within flow simulation. So gases, we have a number of predefined gases. In terms of liquids, we have a number of predefined liquids as well. Non-Newtonian liquids. So within flow simulation, you'll be able to run Newtonian and non-Newtonian fluids. We have compressible liquids, real gases. So if you're running any type of refrigerant type of analysis, cooling systems, typically these days you're using an R410A, so you can find it right here. And we also have steam. So all these are predefined with all the real properties for these types of fluids. Next, you will be able to specify any wall conditions. So if you have any roughness on your wall, if it's an adiabatic wall, or if you want to apply some heat transfer on your wall, or a wall temperature, if it's a heated wall, you'll be able to apply that as well. Flow simulation does take into account fluid and gas bouncing off walls. So if there's a roughness of the wall conditions, you can apply that as well as a micrometer measurement. And last but not least, your thermodynamics initial conditions. So pressure, temperature driven. So for this analysis, I've already pre-set it up, but as a new analysis, you'll be able to pick either pressure temperature or density temperature, density pressure as well. So 2 out of the 3. And in this case, I've picked pressure and temperature as the driving thermodynamics parameter. All right, so those are your initial conditions. The next thing I have is my rotating region. So I specified this as a rotating analysis. So I have this area right here with the fins are rotating. So you can see that how that entire area has been selected, and we have specified a rotation in that area of 1180 RPM. So now the fluid will take into account the geometry of the fins and rotate in that region at 1180 RPM. For our boundary conditions, I did mention our inlet conditions. So we always need an inlet and an outlet for an internal analysis like this. So as the volume is flowing into this pump, it's flowing at 150 gallons GPM. There's an outlet right here, and as it flows out of your system, it's just flowing to environment pressure. And we also have a real wall condition that we've set as part of this analysis, where we've specified as a stator. And essentially, that's all we need to set up this analysis, considering that it's all, again, integrated within SOLIDWORKS and all the geometry is driven by SOLIDWORKS. This geometry is always simulation ready. So there's not a lot of pre-processing that needs to be done for the model itself. Flow simulation works well with the meshing of SOLIDWORKS geometry, so we are good to go to mesh this analysis and run the analysis and run and solve the analysis. So I've pre-solved the analysis, and we can start taking a look at our results. So first off, I like to view the results using some cut plots. It's essentially section views. So I've created 2 cut plots here, and I'll show them. So the cut plots gives you a really good idea of what is going on internally in your system right now. And the color contour gives you a really good idea. So in terms of velocity, right? So right now it's set to velocity, but if you would like to change this, all you need to do is just click this velocity right here, and I can change this to pressure. Say okay, and now it changes it to pressure. So it's very interactive, very easy to change. But changing this back to velocity, I can see the change in velocity as the fluid travels into the pump, and it increases as it rotates in this fin region, and as it departs the pump, the flow rate reduces. So it makes sense. So this is the type of results I want to start with to ensure that I have a good setup for this analysis. So once I'm happy with my cut plots, I can hide those. And the next thing I like to view is the actual flow itself of this fluid. So that's what we call as flow trajectory in the analysis. So let's go ahead and take a look at our flow trajectories. So it is a particle study. It is taking into account each particle of your fluid. So it will take a little bit of time to process the results. So within a few seconds here. So while we're waiting for this to process, let's see if we have any questions that's coming in right now. Okay, so one question I did receive is, can I um, can I use a fan in this analysis? Yes. So in cases where you have an analysis with, let's say, a fan, it's actually very similar to running an analysis like that we just saw, right? So it was essentially rotating the fluid. And when you have your air, or in this case, a fluid or air flowing through your system or out of your system, you could have you could specify it in three different ways. So number one is, as we saw, we were able to just apply an RPM. So we can specify the region, and we can specify an RPM and the direction of the flow, and you'll be able to create that airflow. A second way to create the airflow is to simply specify the mass flow rate of that air coming into your inlet. Um, Lastly, you also would be able to create an airflow using fan curves. So let's say if you have a fan curve. So in case if you purchased a fan from Delta Fan, something like that, typically it comes with a fan fan curve, which you'll be able to input into Flow Simulation and view the change in CFM due to pressure difference due to internal and external pressures. So let's give this a couple more seconds. It is taking a little bit extra time than usual, possibly because I am on this webinar and I'm doing this live. And while we are waiting, let's see if we have any other questions. So no questions at this time. So if you want to ask a question, this will be a great time to do that. Okay. All right, so it looks like the flow trajectory is taking a little bit extra time today due to the webinar and having it project over the webinar. So let's kind of move on from that. So let me cancel that that process right now. All right, so now that we are that we have ran the analysis, so as you'd seen previously with the cut plots, and unfortunately we couldn't see the flow trajectory this time, but one more thing that I can show you is the surface plots. So in this case, we can see the velocity, and just like before, we can also view a pressure plot of the air flowing through the system. Another surface plot that we can see is possibly the pressure on the fins. So in this case, you can directly see the pressure on the fins here. Okay, so now that we have ran and completed the analysis within Flow Simulation, we can actually move on to our SOLIDWORKS simulation. So I'm just turning the add-in on, and you can see here, I have my simulation study pre-set up. And for my loads, actually, I'm not going to set any loads up within the flow simulation itself. Just going to hide this. But the loads, the external loads, are flow effects that come directly from the flow simulation analysis. So you can see fluid pressure options include fluid pressure effects from SOLIDWORKS Flow Simulation. So using the external loads of the fluid pressure, we are now able to run a stress analysis, and we can view the stress results of this analysis. So we also be able to animate. So better view of this is maybe we can do a displacement plot, and we can animate, and we can see how those fins are displacing due to that fluid pressure on it. So it's a really good way to assess if those fins are going to be able to withstand the high fluid pressure that's coming into the pump based on the GPM and also the rate of rotation. Okay, so let's go back to my PowerPoint here. So we're able to view our cut plots. So this was essentially the flow trajectory that we would have been able to see. So it is in real time. It rotates and it flows, and you'll be able to see it as if there was water flowing through the system. It's probably was a little bit too heavy for the webinar as I'm projecting it over the webinar. But if you're doing this at work, just using your basic SOLIDWORKS requirements, basic graphics requirements to run SOLIDWORKS, you'll be able to see that kind of the rotation of the fluid here. There's a lot of more information that you can extract from flow simulation, real values that you would be able to export to Excel. So you can see here volume flow rate, the torque, the static pressure. We can even run what if scenarios if we have different flow rates, 200, 400, 500. And this can be done by just simply cloning the study. So you don't have to rerun the analysis. You just be able to take the initial analysis that we saw earlier at 150 and rerun the analysis at 200, 400, 500 without having to have a user control it. So it can be pre-set up, and you could hit run and leave and come back the next day, and you would have results for all the different flow rates. So you can see how that looks here. So you can see how this is a variable input, 100, 200, 300, 400. We hit run, and you'll be able to get an entire table display as well as graphics display of all the different analysis included. And then once you have all of those results, you'll be able to compare all the different results that you have. So in this case, you can see I have my 200, 400, 150, 500 GPM, and you can compare the pressure head here in graphical format. As well as now my pump curve data, I was able to extract all this within Flow Simulation. Last but not least, we were able to export the results to FEA. And once we are in FEA, we did just view a linear static analysis, but we also have the capabilities to run non-linear analysis. And same process, you'll be able to clone the analysis from linear and just rerun it as the non-linear analysis to get a little bit better results. Considering the fins are thin material, it can deform in a non-linear form. So you'd be able to run a non-linear analysis as well to get a little bit more precise results. All right, so we are almost up in terms of time. So before I let everyone go, I just wanted to let you know that Javelin and SolidWorks are working together to put together some live events for all of you out in West Canada. So it is a live event showcasing very similar to what you saw today, but in much more in depth and it will be live, and you'll be able to interact with the presenters. It will be a few of my colleagues from SolidWorks that will be presenting. So here are the three events and the 3 dates that are available. So if you go onto the Javelin website, you'll be able to register for this. So if you go on to Javelin website, resources, upcoming events, you'll be able to find these events and click on them and register. They're completely free, 100% free, and very valuable, I feel. So please take advantage of these live events.